Hello and welcome back to the channel. Today we are going to have a quick look at the new beta version of Siril, which will hopefully be going live very soon. Some interesting aspects in it, particularly something called SPCC for users of PixInsight that's been around for a couple of years, but Siril is now getting that tool. It's a color calibration tool which I find very useful. I'm also going to be taking a look at how you combine 2 nights worth of data. You can obviously do more than 2 nights, but I've got 2 nights of data on M101. So we're going to have a quick go at processing that in the new Siril. And yeah, welcome back to Ars the Astro. So if you want to have a go with the Siril 1.4 beta version, there are instructions on the Siril website which detail how to do it. It's pretty straightforward. You can copy and paste most of the commands which kind of do it, and there's one application you need to install. But yeah, you basically follow the instructions and it will compile it for you and build it ready to go. I've not had any issues with it so far, and the layout is slightly different, but yeah, let's see how we get on. So this is the new beta version. As you can see, it's pretty much this aspect of it is the same layout, but some of the menus have shifted around. And they've restructured things. So the first thing we want to do is we want to take a look at what we have got. So here we have our 2 nights of data. I've just called it P1 and P2 just so that we can separate them. And we've got all the files, the biases, darks, flats, lights that we normally do when we are stacking an image in Siril. So what I want to do is point as home directory at one of those folders. So you can see I've already got it pointed at M101 P1. OK that. And then what we want to do is, if we look under scripts, Siril scripts, you'll see that I've created this script file called OSC Calibrate Lights. And all that's going to do is it's going to apply the biases to the flats, and then the flats and the darks to the lights, and leave us with ready calibrated images. It's not going to register or stack them, it's just going to calibrate the lights so they're ready for processing. So if I run said script, and it shouldn't take long because it's not doing everything this time. All it's doing is just generating the master files and calibrating the images. That's it. There we go. So that's done its work. We don't need to do anything with that just anymore just yet. What we need to do is swap over to our second night of data and run the same thing again. Just run calibrate lights, let the script run, all done. So what we should now have, get rid of that, is we should have M101 P1 with a process and a masters folder, and we should have the same in M101 P2. So what we're going to do is create a new folder and call it M101 file, and in there I'm going to create a new folder and call it lights, and then we want to copy all the files which are labeled PP light. So if you take a copy of all of those, all 97 of them, copy those, put them into our lights folder, and while that's copying we can go to P2 and we want to do the same again. Now The problem we're going to have is that all the files are labelled the same. So you've got a bunch of files already called PP Light 1 and so on and so forth. So when we copy and paste, copy that, paste it into PMP1 file, it's going to ask us what we want to do. So you want to decide for each, and you want to keep both of them. And it should copy them across, and then you'll just get an extra file. So it'll say PP Light 001, and then there'll be a PP Light 0001 brackets 2 bracket. So now we've got all of our light files, 178. These are all the calibrated images. So now what we need to do is we need to rehome to our final folder, and then I've created another script which is called stack only, which should stack all those images together and produces a final stacked output. So if we hit stack, hit that, you see it's reading all the files, and there you go, stacking is complete. So if we then change our, we're in the final folder, and this is our final result, and we can see we've got a grand total of 53,400 seconds worth of integration time, and that's about 14 hours. So that's a pretty good amount of data we've collected there. We can open that up, we'll give it a quick auto stretch. Now some of my flats on this image weren't great. I think you can see a donut in it somewhere, but we'll get to that in a second. First of all, the first thing I want to do is just give it a crop to get rid of some of the stacking artifacts. So that looks okay to me. Now a lot of this before I was doing in Graxpert, but Siril 1.4 has got a Graxpert interface inbuilt within it. So we can open up, if we go to image processing and Graxpert interface, you see we've got this Graxpert interface for background extraction and denoising. So if we start off with background extraction, hit apply, it will run Graxpert in the background and give us back, there we go, it's with background removal. Now as I say, the flats weren't brilliant on this, so there's a little bit of stuff in the background, but I think we can cope with that, and we can manage with it. So the first thing we need to do now, and this is, I've been trying this for a while and practicing, seeing what the best way of kind of doing this is, we want to do some color calibration. So to use SPCC, what we have to do is first is a plate solve. Now all my data tends to have the right ascension and the declination details within, and the focal length and the pixel size as well. So hitting OK, it should just work straight away. So there we go. So this image is now plate solved inside Siril. Now if we go to the previous version of photometric color calibration and just hit OK, what you'll see is that it gives it a really like orange tint to it, and then when you add colour saturation on it, it makes it even oranger, and that's what I was found was happening with most of my Siril images. So if I go back a step, and then if we go to Spectrophotometric Color Calibration, this is a different tool. So the wide point reference we leave as an average spiral galaxy, seems to work fine. We are a one-shot colour sensor, that's fine. In the OSC sensor, we need to select the sensor that has been used in that we've taken the images with. This one, it happens to be an IMX 294C, but there's options for Canon cameras, Nikon cameras, most of the main sensors. The 585 is in there. And somebody's even put some of these EWR cameras in direct, even though technically the 2600 MC is just the 571. So if you select Sony IMX 294, And then if you've used any filters on it, you also want to choose a filter as well. And there's a small selection of these so far, but there is a way that you can add your own in. There are some instructions on the Siril site you can use, and I've managed to create this UHC filter one because that's the one that I've been using. Everything else in here you can pretty much leave as is, and then all you do is hit OK, and it goes away and it talks to a catalogue from a satellite. It's obviously not talking directly to the satellite, it's just talking to the database which is available, which was created by that satellite, and it will choose a white balance based on your camera and your filter. So as you can see, he's matched that one up pretty good. I think that one's the sensor, and then this one's the filter, and it's tried its best with a filter, but it's there. So, and you can see now it's a lot more white. Now the reason we do it after the background extraction is GraxPert tends to change the colour balance of background during its background extraction. So we do the background extraction first, then run the SPCC, and then now we've done it through SPCC, we can then give it a denoise. So 0.8's fine. Again, hit apply, and that's our image back. Again, we can ignore most of this for now because, as I say, the flats weren't brilliant. There's a couple of donuts in there. I think I was still trying to use the shower cap at this time and this point, and that's changed now. We don't need that anymore. So we can turn the auto stretch off. So we've got his denoise done, so now it's time to give it a stretch. Now I haven't run this through Cosmic Clarity. We'll see what it's like without, and I may redo it later with Cosmic Clarity, but this is just a basic overview of processing again. So we pop into stretches, and we want as generalized hyperbolic transform. First of all, we need to have a look, just have a quick look. Do we want to lower the black point already? Don't think we do. Looks okay to me. And then what we want to do is we want to pick a point on this peak. We'll try to go to the left of it, and that will set as symmetry point for our initial stretch. So we can turn that off, so it goes back to 1:1, and then we can start giving it a stretch. And we pull the data out, give it a chance to catch up, and then we can see our M101 Galaxy in the middle there. Might want to give it a little bit of a local intensity, and what we're trying to do is get it to a point where we can see the darker dust lanes, and which then will become ready in the next step to try and pull them out a bit. So I think we'll go about there, because the centre's not too blown out. We can still see most of the stuff around the galaxy. So we'll try there, and then the next step we want to do is we want to try and pick out some of the dust lanes. So if we select there, and then we can use this little dropper to select our symmetry points, and as we start to stretch, you'll see on the histogram here, you'll see how we're pulling the darker side down and the brighter side up. What we're just trying to do is create a bit of contrast to bring out these lanes somewhat. So concentrating on the lanes, trying to bring the dust out of them. That's good. Looks okay. So then what we need to do is just try and use that highlight protection and the shadows just to try and bring everything else back. So we've still got as contrast, but we're not losing anything in the background. It looks a bit grey, but we're going to sort that very, very soon. So that doesn't look too bad to me, I think. So we will apply that. We will go back to we'll go to linear black point, and then we'll just drop the black point all the way down. Make sure we're not cropping anything across the bottom, so we can nudge it up a little bit more. Starting to crop there, so just come back a little bit. So as you can see, we've got lots and lots of contrast, but we've lost some of the back now. So what we need to do now, so you go back to here, you want to try and bring some of it back. So we'll select a point on the trailing edge of that hump. This hump is all the background, all the actual image data is here somewhere. So we're going to select a symmetry point on that hump, and then we're going to try and stretch it back out again. And you can see we're just starting to bring things back into view. And then we don't want to overwhelm the brightness, so we can bring that back down again. I don't think that looks too bad. That looks pretty good. So we can apply that. What we might want to do is just take some of the green noise out of it. So if we remove green noise and apply, it'll take quite a bit of the green noise about it. And then it needs some colour really. So if we go to, there's two ways to do it. You can do it through colour saturation and then in there, but there's also a way to do it using the saturation stretch here, and just add in the saturation stretch. You can change the symmetry point as well, so we can make it, we'll bring some more blues out. Can bring that down, that up. It's a much easier tool to try and get the colour out you want. Not forgetting the rest of your image as well, obviously. We could have started this with the star extraction first, but I think this is perfectly fine. So let's try and get some bit more blue out of it, and then see if we can curtail. There you go. That's not too bad there. Quite like that one. We've got some blue in there, which was always my major issue with images, was just trying to pull the blue out. And there you go. That's just a very, very, very quick and dirty way of imaging. Now there's a bit of a very quick way of processing. There is a bit of noise in there still, and what we can do is just give it another quick run over with a denoise. That's a little bit better. Yeah, and that's it. That's really a very, very quick and simple way of processing an image. So the flats on this weren't brilliant, so there are little bits of dusty stuff in the background. But as a quick way of processing an image, I don't think that's bad. What you can do is you can obviously, before you start doing the stretch, you can remove the stars. So you're on the stretch in the galaxy, and then you can reintroduce the stars later, so they're not as colour saturated as what these are. As I say, it was just a very, very quick way of processing. So I hope you like that. We'll have a look at focal length and image scale, I think, in the next video, because I got asked a few questions about it recently. So I think it's worth just reviewing what happens with different focal lengths and different pixel sizes in cameras, and why we choose certain cameras for certain things, and and all that kind of thing. But yeah, thanks for tuning in, and we will catch you in the next one. Bye for now.